Eric Burgess here. A plane flies 1.2 hours at 111 miles per hour on a bearing of 38 degrees. It then turns and flies 1.4 hours at a bearing of 128 degrees. How far is the plane from where it started? So just keep in mind with these kinds of problems, when they say bearing and they just give you nothing else about the bearing, they always are referring to measuring it by drawing a line northward. So typically, right, that's up. And then we draw the angle going clockwise. So we're going to really quick sketch this problem. And then using our sketch, we'll solve the problem. So I'm going to go ahead and do what I just did. I'm going to draw a line, and we're just going to call it north. And we're told right at the beginning that we had a bearing of 38 degrees. So I'm going to come over 38 degrees-ish and draw a line. So we went some distance from here. And when we got to this point, we turned. It says we then turn and we fly at a bearing of 128 degrees. So we've got here a new north. Well, it's the same north, still pointing straight up. And then we're going 128 degrees, which is something like that. So we're going to then draw another one. I'm going to make it longer to avoid confusion. Don't stop when you have a line like this, because you can accidentally assume that this over here is a right angle, which you can't assume safely. So it's safer to sketch it where it goes longer. It's a very easy mistake to make. So just be aware of that. So, okay, we've got this. And they want to know, right, let's call this our ending point. And we've got over here our starting point. We want to know how far we are. We want to know this distance here in red, which, as you can see, forms a triangle. We have a triangle here. And we would like to know, how does this stuff work out? How do we find this distance? We'll call this the distance r. So first things first, if we want to use any of our trigonometric knowledge, we're going to need to see if this is a right triangle. So we need to figure out what these different angles are. So it's kind of tricky, right? Because we don't know if this is a right angle or not. It's probably not. And so we're going to use a geometric theorem that says if we have two parallel lines, for example, if I had two parallel lines and then a transversal crossing them, then we can say certain things. Like we can say which angles are equal to each other using these theorems here for geometry, right? These angles match, those angles match. So if we can find two parallel lines with the diagonal crossing them, we maybe can get at some information about angles. And if we look at our north vectors, right, these north lines are always going to be parallel because they're all pointing just straight north. So that means I'll do it here in blue. We have a line here and we have a line here. And we've got a transversal, this diagonal line right here. So that means we can say something about this 38 degrees. If this is 38 degrees, then this angle must also match the 38 degrees. It has to be the same. So we know that this is 38 degrees. So that's just a little geometric theorem. It's going to be a very useful one for you to know. So definitely commit that one to memory and learn about the parallel lines and the transversal, all the different angles that match. It's pretty handy. So now that we know that this is 38 degrees, we want to see if we can figure out the other angles. And I didn't label one of our angles, so that's going to be our other piece of information, right? We said that this angle right here was a bearing of 128 degrees. So that's 128 degrees. Well, we know that this right here is a flat line. And so our angles, when they're drawn like this, they have to add to 180 degrees, right? Because that's going to give us a straight line. So that means that if we take 180 minus 128, we're going to get whatever goes here. So I'm going to grab a calculator. I'm going to do 180 minus 128. And we get 52. So we got 52 here. So this is 52 degrees. And now we know both halves of this angle. So if we simply add these, we can figure out what this is. So if we had 52 plus 38, 8 plus 2 is 10, 5, 6, 7, 8, 9. We have 90 degrees. So we can see that this is a right triangle. This is great because it means we can use the Pythagorean theorem and a bunch of other trig stuff. Now there's something else we need to do, right? We have information about how long the flight happened and at what speed. And that means that we can use the formula distance is equal to rate times time. So in this case, for our first trek of the journey, we went 1.2 hours. So this is 1.2 hours. And we were going at a rate of 111 miles per hour. Miles per hour. And you know we've got the right formula because the hours cancel out and we're left with miles, which is a unit of distance. So I'm going to put a little I next to it to show that it's miles. So we need to do 111 times 1.2. We get 133.2. So that means that this first part of the journey was 133.2. Now for our second part of the journey, right, we turned and we went 1.4 hours and we went at the same speed. And I did not write that down, so that's going to be really hard to know. But yes, it's supposed to be that we went at the same speed. So we're still going at 111 miles per hour. In fact, the lack of a mention of a change of speed would mean that we would need to assume that this is here. So we're going to go 111 miles per hour, or I guess you could get up and ask the professor. And we're going to do times 1.4 hours. Units cancel out. We're left with miles. These are in miles. So we're going to have 111 times 1.4, and we get 155.4 miles. So this is 155.4 miles. Now, because this is a right triangle, you might want to use sine or cosine, and we can actually do this to check our answer. So first we're going to do it using the Pythagorean theorem. So R is across from the right angle, right? This would be a giant right angle. Since R is across from it, that makes it the hypotenuse. So that means that we can use the Pythagorean theorem, which says that the square root of the two side lengths squared, 133.2 squared, plus 155.4 squared, has to equal R. And there's a negative version of R as well, but because we're doing units of distance, we ignore the negative solution. So we're going to get R is equal to, and we're going to take the square root of this. So we're going to have the square root of 133.2 squared plus 155.4 squared. And we get R is 204.67. And don't forget, it's in miles. And this would be our answer. This is the distance that the plane is now, how far away it is from where it started. Now, there's another way to do this. We can use tangent. Now, we don't know what this angle here is. It's a mystery angle. Let's call it phi. We don't know what it is, but we do know the adjacent side and we know the opposite side. So we could use a tangent to figure it out. So we could use tangent of theta is equal to, and it's going to be opposite 155.4. Let me move the calculator. And then over 133.2. And if we take a tangent inverse to both sides, so we tangent inverse this, and we tangent inverse this, we're going to get that theta is equal to, and then using our calculator, we're going to take a tangent inverse is right here in blue. So I'm going to use second inverse, 155.4 divided by 133.2. And we're going to get out an angle of 49.3. We'll round it to the nearest decimal. So 0.4. 49.4. So that means that phi is equal to 49.4. Now using this, we can use sine or cosine to get it r, right? Because we know the adjacent or the opposite. I'm going to go ahead and just use sine. So sine of this angle, 49.4, has to equal the opposite, which is 155.4, over the hypotenuse r. Solving for r, we get 155.4 under sine of 49.4. And if this step threw you off, just go through the motions, multiply by r to both sides, and then divide by sine of 49.4 to both sides. You'll get the same thing. So now r, we would expect r to be what we have down here. If it's different, that's evidence of a mistake somewhere. So let's go ahead and do this. So we're going to go ahead and do 155.4 divided by sine of 49.4. And we get 204.67 if we round it. And so we get the same thing. We could write the glorious as expected next to it. And there you go. You can walk away from this problem extremely confident that this is the correct answer. And you've got yourself the distance that the plane went. If you have any questions about this, feel free to let me know. Subscribe and hit that bell icon for future videos. And we'll catch you in the next problem.